Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad Shauki bin Aman, and today I'll be representing Group 6 on study on effect paper airplane parameter flying distance using Taguchi method. Firstly, the introduction. The Taguchi paper aircraft experiment is a teaching exercise that draws inspiration from the idea of the Taguchi techniques, which were created by Junichi Taguchi, a Japanese engineer. By eliminating variance and lowering a system's susceptibility to outside influences, Taguchi techniques aim to improve the quality of processes and products. Designing and building a paper aircraft that can fly the furthest, or accomplish a certain purpose is usually the aim of a paper airplane experiment. The experiment is a fun method to teach participants, who are frequently students, the fundamentals of optimization, experimental design, and the significance of controlling variables to get better results. Next, the objective of this experiment: to investigate the impact of control factors such as height, weight, and design on the flight distance of a paper airplane. Second, to apply statistical analysis techniques to the experimental data to identify the significant factors and their respective levels that influence flight distance. Thirdly, to assess the effect of noise factors on the flight distance and integrate this into the analysis. Fourthly, to determine the optimal settings of control factors that maximize the flight distance of a paper airplane. And lastly, to identify the most effective combination of control factors levels that produces the longest flight distance. Next, the design of a paper airplane greatly affects how far it can fly. Key factors include the type of paper, wing shape, body design, and balance. Lightweight and stiff paper improves flight, while a wider wings add lift but slow the paper plane down. Narrow wings are faster but less stable. The streamlined body and a pointed nose reduce drag, allowing longer flights. Proper weight distribution, such as adding a paper clip to the nose, helps keep the plane stable. Tails or stabilizers prevent spinning and improve direction. Paper planes are not just toys, they are tools for learning and innovation. Engineers use them to test ideas before building real aircraft. Platforms such as YouTube, TikTok, Google provide creative designs that push the boundaries of flight performance. Next, parameters play a key role in determining how well a paper airplane performs. In experiments, they help identify the best combination of factors to achieve the longest flight. There are two main types: control factors and noise factors. Control factors are the variables we can adjust, such as the plane's design, type of paper, and folding technique. Noise factors are unpredictable elements like wind, throwing strength, or slight difference in materials. Understanding both types is essential for improving flight performance and ensuring consistent results. The parameters for the experiment were selected. The control factors were: firstly, design of the paper airplane, weight, and height. The noise factors in this experiment were indoor conditions and outdoor conditions. Next, orthogonal array. The orthogonal array table was constructed using three control factors: paper plane design, A, B, C, weight, 70 GCM, 140 GCM, and 210 GCM, and height, 100 cm, 150 cm, and 200 cm, forming a total of 9 experimental runs based on an L9 orthogonal array. The design allows efficient testing of multiple factors with minimal trials. Each experiment was tested under 4 different noise conditions: indoor and outdoor throws by two individuals, Fikri and Kavin, to account for external variability such as gender and angle of throw. For example, in experiment 1, design A, weight 70 GCM, height 100 cm. The average distances thrown under each condition were recorded, allowing for detailed comparison and identification of the most effective factor combination for optimal paper plane flight performance. Next, methodology. Building an orthogonal array table. To build the orthogonal array table, 3 control factors were chosen: design, weight, and height, each with 3 levels. Using the Taguchi method, an L9 orthogonal array was created, resulting in 9 different combinations of these factors. This method helps test all factor combinations fairly with fewer experiments. Noise factors like gender and throwing angle were included during testing but not controlled, so their effects could be averaged out. Each experiment was tested under 4 conditions: indoor and outdoor, and thrown by 2 different people, and the distances were recorded to compare performance. Next, Taguchi method calculation. In this experiment, the Taguchi method was used to study how design, weight, and height affect paper airplane performance. Each factor had 3 levels, so an L9 orthogonal array was used to create 9 different combinations. These 9 setups were tested under 4 noise conditions, indoor and outdoor throws by 2 different people, to include real-life variations. For each experiment, the average flight distance was calculated from the 4 tests. Then the signal-to-noise ratio, SNR, ratio was found using the larger the better formula, since longer distance are better. After that, the average SNR ratios for each level of each factor were compared to see which had the best effects. The levels with the highest SNR ratios were chosen as the best combinations for making the paper plane fly the furthest. Example of Taguchi method table. Since larger the better formula is used, the formula used to calculate the mean of square for larger the better is shown in figure with the formula shown. Signal to noise ratio for larger the better. The signal to noise ratio is calculated by using larger the better after having all data calculate the overall mean, and control factor effect calculate for every control factor: design 1, design 2, design 3, weight 1, weight 2, weight 3, size 1, size 2, and size 3. These are sum of square due to factors shown in the tables in this slide. This is to calculate total sum of square. Next, calculate percentage influence. The percentage of influence is 100%, in bracket sum of square due to factor over total sum of square. To calculate the error, once the results have been obtained for the repetition experiment, error needs to be calculated so that Taguchi experiment results can be validated. The percentage error is equals to, in bracket, prediction minus repetition over repetition times 100%. The Taguchi methodology is a methodical and successful way to optimize processes, parameters, and enhance the quality of both the products and the process. It is applicable to both qualitative and quantitative data and identifies important aspects driving performance. It allows for cost-saving enhancement by measuring variation-related losses during the loss function. Widely utilized in industry, it improves efficiency, lower waste, and improves manufacturing performance. Its practical application facilitates quicker data-driven decisions and boosts customers' satisfaction and organizational competitiveness as a key instrument in design of experiment, or DOE. Thank you. That's all from me, the representative of Group 6.